Welcome to ClickMyProject.com. Let me discuss about the project, a new data hiding method based on Chau's embedded genetic algorithm for color image. Let me discuss about the abstract of the project. Data hiding is also known as data encapsulation or information hiding. It reduces system complexity. For increased robustness, proposed approach provides optimal solution for performing data hiding. Here, secret data is to be generated based on the various chaotic mapping approaches. Then the generated chaotic sequences are embedded into cover images by particle swarm optimization method. In PSO, optimal solution is achieved, which is calculated based on the maximal PSNR. Finally, the stego image has been generated with minimal changes of the cover image. Chaotic map is a map that exhibits some sort of the chaotic behavior. Maps may be parameterized by a discrete time or a continuous time parameter. Discrete maps usually take the form of iterated functions. Chaotic maps often occur in the study of dynamical systems. Chaotic maps often generate fractals, although the fractal may be constructed by an iterative procedure. Some fractals are studied in of themselves as sets rather than in terms of the map that generates them. This is often because there are several different iterative procedures to generate the sum fractal. Particle swarm optimization is a population-based chaotic optimization technique developed. PSO shares many similarities with evolutionary computation techniques such as genetic algorithm. The system is initialized with a population of random solution and searches for optima by updating generation. However, unlike GA, PSO has no evaluation operator such as crossover and mutation. In PSO, the potential solutions called particles fly through the problem space by following the current optimum particles. The detailed information will be given in the following sections. Let me discuss about the flow diagram for our process. Initially, read the cover image from the dataset folder. The cover image has different dimensionality, so have to resize the cover image into predefined dimensions. In order to reduce the noise, here Wiener filter used for filtering noise from image. The Wiener filter is a filter used to produce an estimate of the desired or target random process by linear time invariant filtering of an observed noisy process, assuming known stationary signal and a noise spectra and additive noise. The Wiener filter minimizes the mean square error between the estimated random process and the desired process. Wiener filter is based on the statistical approach, and a more statistical account of the theory is given in the minimum mean square error estimated article. Next, here the chaotic map generation, that is data bit generation, has been proposed. Chaotic map is a map that exists some sort of the chaotic behavior. Maps may be parameterized by discrete time or a continuous time parameter. Chebyshev map. Chebyshev map is a symmetric region map. It is used for security problems and neural networks. Initially, the first bit is generated randomly using rand src function, where the bits are generated between -1 to 1. Next, the logistic map. The logistic map generates between 0 and 1, which is a polynomial map. Initially, the first bit is generated randomly using rand function, where the bits are generated between 0 to 1. Next, the sinusoidal map. Sinusoidal map generated bits between 0 and 1, which is a polynomial map. Initially, the first bit is generated randomly using rand src function, where the bits are generated between 0 to 1. Next, data embedding. So data embedding is the steganography is a technology of hiding data into digital media without drawing any suspicions. It can be used to carry out hidden exchanges of information and to provide privacy for the user. A message are inserted into the cover image by using stego key. Main issues in steganography are capacity and security. A secure and efficient mechanism must be provided before covering the information. Data embedding technique is one of the methods used for hide the messages over the image. In this paper, we are going to analyze various algorithms in data embedding technique. The edge adaptive message steganography. Next, the particle swarm optimization, where the particles are initialized. Particle swarm optimization might sound complicated, but it is really a very simple algorithm. Over a number of iterations, a group of variables have their values adjusted closer to the member whose value is closest to the target at any given moment. Imagine a flock of birds circling over an area where they can smell a hidden source of food. The one who is closest to the food strips the loudest, and the other birds swing around in his direction. If any of the other circling birds comes closer to the target, then the first it chirps louder and the others veer over toward him. This lightning pattern continues until one of the birds happen upon the food. It is an algorithm that's simple and easy to implement. The algorithm keeps track of three global variables: target value or condition, global best value indicating which particles data is currently closest to the target, stopping value indicating when the algorithm should stop if the target isn't found. Each particle consists of data representing a possible solution, velocity value indicating how much data can be changed, personal best value indicating the closest the particle's data has ever come to the target. Here the fitness has been evaluated. Here PSNR is calculated in the fitness function. Next, the G-best value only changes when any particle's P-best value comes closer to the target than G-best. It is also common to PSO algorithm. Finally, if the maximum iteration is reached, then the process are terminated. Finally, the performance has been analyzed. PSNR is most commonly used to measure the quality of reconstruction of lossy embedded codecs. The image in this case is the original data and the noise is the error introduced by embedding. The bit error rate is the number of bit errors per unit time. The bit error ratio is the number of bits errors divided by the total number of transferred bits during a study time interval. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, like that file and run for executing this process. Here we have to select any one common images from the dataset folder. Here choose any one method for data generation: random, Chebyshev map, logistic map, sinusoidal map. Here I select Chebyshev map. And now the genetic algorithm process are executing. This will take much time for execution. After performing 20 iteration, we are performing particle swarm optimization algorithm that will also perform for 20 iteration. And from both the algorithm we estimated the PSNR value. And this is the cover image, and this is the cover image pixel values. This is the resized image, and this is the resized image pixel values, and this is the here, this is the data bit value which are using generated using Chebyshev map, and this is the data bit graphical representation, and this is the embedded image without performing any optimization, and this is the embedded image pixel values without optimization result. This is the received data bit without optimization result after de-embedding process. This is the resultant data without optimization after performing de-embedding. This is the embedded image with GA optimization, and this is the embedded image pixel values with GA optimization, and this is the received data bit with using GA optimization after performing embedded result. This is the resultant data graphical representation using GA by performing data de-embedding. And this is the embedded image with PSO optimization, and this is the embedded image pixel values with PSO optimization, and this is the received data with PSO optimization after performing de-embedding, and this is the resultant data bit using PSO after data embedding, resultant data graphical representation, and this is the capacity PSNR change rate. This is the PSNR graph versus capacity. Finally, we embed the data into image and using maximal PSNR by PSO algorithm and genetic algorithm and compare the result. Thank you.